The structure of the Earth is quite simple. We have a core, a mantle and a crust, a little bit like a boiled egg, I suppose. The yolk, our core, is actually metallic. It's made of mainly iron and nickel. The outer part is liquid and the inner part is solid. Outside that we have the mantle of the Earth, and although the basalts that come from the mantle are black, such as this example here, the mantle itself isn't, and we have a piece of the mantle here. It's a beautiful green colour, and the predominant mineral in this piece of the mantle is olivine. The mantle is quite plastic, and so it deforms and circulates very slowly. And the last layer, which is a very thin layer, is the crust. Most of the crust is actually made of basalt, and it lies beneath the oceans, so we don't see it. The parts that are very large and sit out of the oceans, the part that we live on, the continental crust, is much more buoyant and made of rocks like this granite. So although the Earth doesn't feel hot to walk on, to step on, it actually does get progressively hotter with depth, and it's extremely hot in the core of the Earth. Because the mantle is very slow at convecting, it's very inefficient at bringing that heat to the surface, and of course the crust of the Earth acts like a blanket and keeps the heat in, so it's only where we have things like volcanic eruptions, for example, that the heat is really efficiently lost. The outermost rigid part of the planet is broken up into a series of plates, and these move in different directions. It's really easy for us to spot where the edges of those plates are, because where they move apart we make new ocean crust, like at mid-ocean ridges. Where they grind past each other we tend to get lots of earthquakes. The San Andreas Fault would be a good example of that. And where the plates collide and one's pushed back into the mantle, we tend to get lines of both earthquakes and volcanoes. And so the Andes, I guess, would be a good example of that too. In parts where that subduction process, where one plate is driven back into the mantle, bring two continents together, because the continental crust is very buoyant, neither wants to get pushed back into the mantle, and so they collide and we get big mountain ranges, and the Himalayas would be probably our best example of that. So much of what we understand of the structure of the Earth really comes from seismic waves that are created by earthquakes and the way they pass through the Earth and out the other side. In addition to the seismic waves that give us an idea of the structure of the planet, sometimes volcanic eruptions will sample the deep mantle or the lower crust and bring pieces to the surface that we can examine. I guess what really excites me is that although we're really familiar with the surface of our planet and the small part that we live on, the continental crust, we're less familiar with what's directly beneath our feet. So we'd only have to go a few hundred metres, kilometre, and it's all very mysterious, which is kind of exciting.